Okay. So what is a sill excluder? A sill excluder is a structure in the undersluice's pocket to pass the silt water to the downstream so that only clear water can enter into the irrigation canal. Okay. And next is your guide bunch and marginal bunch. Guide bunch and marginal bunch, these are provided in the river. Guide bunch are provided on either side of the diversion headworks for a smooth approach and to prevent the river from outflanking. Marginal bunds are provided on either side of the river upstream of diversion headworks to protect the land and property which is likely to submerge during ponding of water in floods. And wear and berries. So already you have got what is wear and berries. A diversion network is a structure constructed across the river for the purpose of raising water level in the river so that it can be diverted into the off-taking canals. A weir is a raised concrete crest wall constructed across the river. It may be provided with small shutters on top. On we maintains a constant pond level on upstream side so that the water can flow into the canals with a full supply level. If the difference between the pond level and the crest level is less than 1.5 liter, so weir is usually constructed. On the other hand, if this difference is greater than 1.5, a great control barrage is generated. Okay. So on the other hand, if the difference is greater than generally these are theoretical points on where, how it works, where it is provided, what is the function. Okay. During dry period, these shutters are raised to store water up to the port level. Generally, the shutters are operated. All the details are not required. Only the what are the functions, advantage, disadvantage. Only that one, those required. Okay. Advantages, disadvantages of weirs and barrage. Weir advantages, the initial cost of weir is usually low. Disadvantage, it is large efflux during the flood, which cause large submergence. Because the crest is at high level, there is great shielding problem. The rising and lowering shutters on the crest is not convenient. Moreover, it requires considerable time and labor. The weir lacks an effective control on the river during floods. Next is barrage advantage. The barrage has a good control on the river during floods. The outflow can be easily regulated by barrage gates. The efflux during floods is small and therefore the submerged area is less. There is a good control over silt entry into the canal. There is a good control over flow conditions, soil formation, and cross currents on the upstream of the barrage. There are better facilities for inspection and repair of various structures. The roadway can be conveniently provided over the structure at a little additional cost. There are better facilities for inspection and repair of various structures. There is a good control over flow condition, soil formation, and cross currents on the upstream of the barrage. A roadway can be conveniently provided over the structure at an additional cost. Disadvantage. The initial cost of barrage is quite high, and so what we have, we can conclude it that a barrage is generally better than a weave structure. Most of the divergent headworks these days usually consist of barrage. Okay, so barrage is provided. Next, types of weave. Types of weave, it may be vertical dropway, rock fill, concrete glacis, or sloping ways. Vertical dropway. A vertical dropper consists of a masonry wall with a vertical downstream face and a horizontal concrete floor. The shutters are provided at the crest, which are dropped during flood so as to reduce a flux. The water is ponded up to the top of the shutters during the rest of the period. Vertical drop weirs are quite common in early diversion headworks, but these are now becoming more or less. So in this figure, you can see this. This is the structure of a vertical drop wing. Sheet pile is provided in the foundation level. So generally, weirs are concrete structures. Okay, not hardened, not made up of earth, soil. It is a concrete structure. Rockfill weirs. In a rockfill type of weir, in addition to the well, let me check. Mm, Next, we have canal irrigation. And next one is rockfill types. In a rockfill type, in addition to the main weir wall, there are a number of core walls. The space between the core walls is filled with the fragments of rock called rockfill. These are the rockfill. A rockfill weir requires a lot of rock fragments and is economical only when a huge quantity of rockfill is easily available near a weir site. It is suitable for the fine sand foundation. The old Okhla weir made across the Jamuna River is a rockfill weir. Okay? Such weirs are also more or less obsolete these days. Next is concrete sloping weir. Concrete sloping weirs are or glacis weirs are relatively recent origin. The crest has glacis on upstream as well as downstream. So in concrete sloping, it has a slope in the downstream, so as well as in the upstream area. Both side it has slope, different slope. The crest has glacis on upstream as well as downstream. There are sheet piles or cut-off walls driven up to the max. What is sheet pile? So these are generally provided in the foundation level. Sheet pile. Um, and these are used to provide temporary and permanent walls. Okay, in the figure you can see the sheet piles here. So sheet piles, these are provided temporary or sometimes permanent walls in the construction. Sheet piles are used to excavation support and soil retention. So these are provided for support and soil retention. Okay. Sometimes an immediate pile is also driven at the beginning of the upstream glacis at the end of the downstream glacis. The main advantage of sloping weir over the vertical drop is that it has a hydraulic jump and is formed on the downstream glacis for the dissipation of energy. Therefore, the sloping weir is quite suitable for large drops. Mode of failure. So how these irrigation structures are failed. So in last class I have provided the notes, isn't it? I have provided last class notes or I have given or not? Last class notes. Okay. So mode of failure. Irrigation structures for the diversion and distribution works are weaves, barrage, head regulator, distributory head regulator, cross drainage works. These structures are generally founded on alluvial soil, which are highly pervious. Moreover, these soils are easily scoured when the velocity of water passes over the structure is more. The failure of weirs constructed on the permeable foundation may occur due to various causes, which may be broadly classified into the following categories: failure due to subsurface flow, failure due to surface flow. So, what is the failure due to subsurface flow? The failure due to subsurface flow may occur by piping or by rupture of flow due to uplift. So, what is piping? Generally, piping is occurs in a way if the water percolating through the foundation has a large seepage. So, piping generally occurs due to the seepage. What is seepage? When the water is flowing out from a structure, then there may be seepage, okay, leaking of water. That is your piping. So piping or undermining occurs below the wheel if the water percolating through the foundation has a large seepage force when it emerges at the downstream end of the impervious floor. So when there is a heavy force of water, there might be a failure of this heavy force, and one of the mode of failure is failure by piping. When a seepage force exceeds a certain value, the soil particle are lifted up in the exit point of the seepage. With the removal of the surface soil particles, there is further concentration of flow in the remaining portion and more soil particles are removed. The process of backward erosion progressively extends towards the upstream side and a pipe-like hollow formation occurs below the floor. The floor ultimately subsides in the hollows, so form and fails. This type of failure is known as piping failure. Next one is failure by rupture of floor. Failure by rupture of floor. The water percolating through the foundation exerts an upward pressure on the pervious floor called uplift pressure. Failure due to surface flow, failure due to suction pressure, and failure by scour. So these are the all failure related failure you can study yourself. Okay. Next chapter we are going to discuss about canal irrigation. Okay. Uh, this chapter includes canal regulations, direct sluice, canal drop, cross drainage walks, canal outlet, design of prismatic canal, canal alignment, canal lining, Kennedys and Lacey's regime theory, and design of unlined canal. So here we are going to study about lining of canal, unlined canal. Okay. So first of all, we should know what is a canal. A canal is an artificial channel, generally trapezoidal in shape, constructed on the ground to carry water to the field, either from the river or from a reservoir. Okay, so this is generally a passage of water, artificial channel. Okay, canal regulation. Any structure constructed to regulate the discharge, full supply level, or velocity in a canal is known as regulation wall. And where these canals are located? What is the location? What are the types? So head regulation or head sluice located barrage with them. Cross regulator parent canal, distributed head regulator off-take canal, canal fault parent canal, or off-take canal. Canal escape on any type of canal, canal outlet or distributary canal. Next is your types and purpose. Head regulator or head sluice. To divert water to parent canal from a barrage. Cross regulator. To head up water in the parent channel to divert some water. Okay, what is the purpose of canal outlet? To take out water for delivery in the field channel or water courses, canal escape, to allow the release or excess water from the canal system. Next is canal fall, to lower the water level of the canal. Next is distributary head regulator. What is the function? To control the amount of water flowing into the off-take channel. Next, cross regulator to head up water in the parent channel to divert some of it through off tech channel or distributary canal. Head regulator or head sluice to divert water to parent channel from a barrage or weed. So these are the canal regulators. In this figure, you can see this is the canal. Suppose this is the parent canal. Here it divided into head regulator and cross regulator. New off-taking canal. This goes to new off-taking canal and a head regulator provided and the head of the off-taking canal. So here in the diversion portion, so this is the main canal, isn't it? It is diverted into two parts. Here in a canal there is a head regulator. Why it is provided? At the off-taking channel and it controls the flow of water entering into the new channel. So this will be a new channel, isn't it? So to control the water entry, here we provided a head regulator. Okay, have you understood what is head regulator? Next, while a cross regulator may be required in a main channel downstream, the off-taking channel it is operated when necessary. So as head up water on its upstream side and thus to ensure the required supply in the off-taking channel even during the period of low flow in the main channel. Next is main function of the head regulator. This is important. Head regulator, the function of head regulator is important. So where it is located? In this figure, you can see head regulator is located here. So what is the function? To regulate or control the supplies entering the off-taking canal, to control the entry of silt into the off-taking canal, and to serve as a meter for measuring discharge. Another function is it consists of a raised crest with abutment on both sides. The crest may be subdivided in various ways by providing piers on the crest. The piers support roadway and a platform for operating gates. The gates control the flow water crest. Okay, so let's take a 5 minutes break. Don't go anywhere. I will come back like 2-3 minutes. Okay. Wilson never. Uh, okay. So Wilson never. Why are you so late? Why are you join so late? Yes. What happened? Classes started on already from 2:30 to 35, and you have joined now. Why? Should I give absent? Okay. So what we are discussing? We are discussing about different function of head regulator. Okay. So what is a head regulator? It controls the entry of flow in a new channel. The gates control of the flow over the crest. They are housed and operated in groups made in abutment. Sometimes the gates are provided in tires, then lower tires may be kept close to raise the silt of the regulator. The head regulator is generally constructed with masonry. It should be founded on a good rock foundation. It should be safe against shearing, sliding, and overturning. This is the shear failure. This is the sliding, and this is the overturning. Okay, three modes of failure. It should be flanked with adequate wing walls. The head regulators should also be given proper protection by providing aprons on upstream and downstream side of a barrel. Okay, to prevent seepage cutoff is also essential. To take irrigation water at low velocities, waterways at the head regulator should be sufficiently big. Oh, you are dear, but in my Wilson, in my screen, it is showing Wilson Deberma is waiting in the lobby. That's why I have asked. Okay, I think you have joined, but you left. So these are the cross section view. In this figure, you can see the cross section view of a head regulator. Okay, this is the roadside. This is the top of the bank. This is the river side. This is the road, top of the bank, downstream, cistern floor. And if you cut any section, here you can see this is the pier, these are the gates, cistern, towel. Okay. Next is cross regulator. Generally, main function of a cross regulator is to control the entire canal irrigation system. And it also helps in heading up the water on the upstream side and to feed the off-taking canals to their full demand. Next, to help in absorbing fluctuations in various sections of the canal system and is preventing the possibilities of breaches in the tail reaches. Cross regulator is often combined with uh, bridge and falls if required. Next is your canal escapes. It is a side channel constructed to remove surplus water from an irrigation channel. The water in the irrigation channel may become surplus due to mistake, difficulty in regulation at the head, excessive rainfall in the upper reaches, outlet being closed by cultivators as they find the demand of water is over. Okay, next, we'll continue in the next class. Next class, we'll continue. I think my meeting is about to end. Let me take the attendance as soon as possible. Okay, let me take the screenshot of your attendance. Then I will put in the attendance sheet. Okay. So, Bemisha Leberma, Christ Oxam, Deepak. Let me take a screenshot. 29 student present. Wilson Jamir, Vika Chohe, Wilson Deberma. Okay, sorry. Walishan Jamir, Vika Chohe, Wilson Deberma, Chase So, Viko Crow, Shenjam, Benishan. Are you there? Benishan? Raju, Purit, Temi, Pokoto. Yes. I just searching your name. Fiba Taba, Oniam Nivia, Nuksimungla Zamir, Marilyn, Margak Mayak Madhusmita, Lord Temenjen Pongar, Larry Kengbam Jesila, Kishan Sabam, Kilitoli, Rupasri, K. Honu, Josnalin Jodha, Imliangar, Gyani Zamatia, Price, Deepak, and Bemisal. Okay. So next class we will continue. Okay, and I will give some actual field related photographs also. Actually, for this canal regulator irrigation canals, we should have a uh, field view, field project. Okay, field what is called field trip, so that you can understand what are the things in actual field. Okay, so I think this semester we are not we cannot arrange the field trip, but I will show some field related, the structure related to field. Okay, how it is actually works in irrigation system. Okay. Okay, thank you.